Hello. Let me lower the music volume. I hope it's fine. Like, it should be like a quiet background distraction. Hi Avito. Hello everyone. We are going to continue the game that we were making on the last game dev stream, which is Breakout. So here we have our little Kanban board, but maybe I will just show what we have already made. So that's basically it. We have the paddle, we have the bouncing ball, we have bricks which are like initialized in the loop, so we didn't have to put them by hand. And we have some basic score. And I also made those sprites by myself. But the creative process was offline. So yeah, apparently we don't have... we still need to implement score and lives. Okay, we already have some simple scoring system. We don't have any sounds. And we don't have any way of, dying. So yeah, here in brick destruction, there was a condition that the ball speed should increase as bricks are broken. So we are going to implement that. And that's gonna be it for the brick destruction task. So we are following, not this, the 20 games challenge. We might need the Godot engine documentation. So yeah, we are making game number 2, and I've selected Breakout because it was different than the Flappy Bird. We did reuse some code, but not a lot of it. So yeah, this is what we are going to make. We also have some stretch goals, which are a safe high score. And I also saved some links to the documentation about the file system. Yeah, from what I understood, Godot uses the relative paths. Like, it's all relative to the game folder, if I remember correctly. There's also like a user path. This path resolves differently depending on the OS. So it's like on Windows, it will be on like, what's the directory name, users? Something like that. So yeah. And it's something like USR on Linux. I don't know much about Linux. Yeah, so let's do that ball speed increase thingy, because now, in the original Breakout game, the ball was at some point, like halfway through the game, the ball was going like at a very, very high speed. Okay, now it's moving horizontal. No, it isn't. It slightly goes down. But it kind of looks bad. I also implemented some randomness to the bounce. Like, there's like, I think 10% chance that the bounce will not be perfect and it will have like a slightly different angle. Okay. What do we have? we have the ball script, which uses the physics stuff. Ball velocity, we need to have some way to change that. Why does it open the brick scene? It is exported. So the ball is included within the game scene. I think like the most simple thing that we can do will be something like this. Ball, we should have access to the exported, yeah. Ball velocity, and oh, it's a vector. It's not a number. So maybe we should have, like, we can increase that ball velocity length, I think. Like, if we can try, but I would like to try some different approach. But let's try, like, multiply it by 1.1. Let's see if we even notice that it is getting faster. It is. With each destroyed brick. So the problem might be that this is going to be too fast. Whoa, yeah, now it's already like too fast. Yeah, this is way too fast. All right, but it works. So yeah, but we are in a God mode, so yeah, it obviously works. But would be nice to have some kind of scaling, right? Also, it would be easier if the ball velocity was like a scalar, like a number, not a vector. So yeah. So maybe we should rename that to not velocity, but ball direction. Replace all. And this is like diagonal, 150 by 150. Isn't it going to go downwards? Yep. Oh, yeah. We don't need that for now. So where is the ball script? So I've seen one thing, it's called normalized. It makes like any vector returns the result of scaling the vector into unit length. So it will be like a 1 unit long vector, and we will multiply it by some number, which will be like a velocity. Do we need to do you want to export that? Let's leave it exported for now, so we can like change the ball direction from here, like override it. So the ball speed. So it was like 150 by 150, so it was like slightly above 100. Get the bounce angle. Oh, we were doing some kind of shenanigans here. Bounce rotated by extra angle. Extra angle was what? Integer? Do we want it to be integer? No, wait. You rotate by float in radians. We kind of don't want this to be integer. So bounce variance. 15 degrees is a variance. Oh, it was like adding or subtracting 15 degrees randomly to the bounce. Okay. So the function would either return minus something, 0 or plus something, and that something is like 15 degrees in radians. So this is fine. No, this should be float. Integer by let's set the type here to float. I would rather have those types specified so it's easier to see what is what, because I'm not sure if the editor is not giving you hints about the type. You need to like check the function and the return type. Okay. Ball direction. So now it's going to be super slow, right? Yeah, it's barely moving. Direction, it's normalized, bounce, rotated, and we just need to multiply it by ball speed, and now it should be much faster. It is not. Oh, we need to provide the delta as well. Okay. So the delta is the time between each physics process call. So if something happens and the game like slows down, this will give you like a bigger number, so you can like move the objects like further. So it's just to make sure that the game will work at a steady speed. Like it shouldn't matter if you have like 30 FPS or 60, like the perceived speed should be the same, like roughly the same. It's still super slow. Does it even work? Something is wrong here. Oh wait, ball direction, we shouldn't multiply the ball. We are just multiplying the direction. Wait a second, where is the... How do we make it moving? Oh, move and collide? By vector. Oh, I see. Wait, why do we... Oh, here we should multiply it by... Wait, should I... No. Should I perform move and collide first? Probably, right? Because how do we detect the collision? Okay, now here, I think it's here where we multiply it by ball speed. Yep. Okay. Okay, it still takes some time to remove the last brick. Yeah. Wait, I think it's like... No, it's not deterministic. We have some randomness. Okay. So would be nice to have some range of speed. Like we don't want it to go to some insane speeds. We also kind of don't want to have those angles. Let's increase this to like 2000. Is it fine? Yeah, that bouncing is clearly broken. Oh, how did I... No, now it's too fast. So how about 1500? Is it fine for the max speed? The paddle is too slow now. Yeah, the paddle is way too slow. Let's increase the paddle speed to, I don't know, 750? No, it's too fast. I mean, the paddle is too slow and the ball is too fast. How about 1200? Whoa, 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 whoa. Is it first speed? I don't want this to be like unplayable. It kinda is at the moment. Let's leave it at 1000. I think 1000 should be, yeah, 1000 should be okay for like a... For the situation when there's like almost no bricks left. Yeah, should be fine. Oh, you can stop the ball. Huh. Wait. Okay, we will worry about that later. So let's try to find what the starting speed should be. This will be way too slow, right? No, yeah. How about 300? This looks fine. Okay. Okay, so let's say const minimum speed would be 300. And cost max speed would be, what was it, 1000? Yeah, I think it was 1000. Okay, so what I would like to have, we could either, like we can like count how many bricks we have and like increase the speed proportionally. So let's say we will have like a scale from 1 to 100 or like 0 to 99, and we will like increase the speed by the percent of bricks broken. That could be nice. So columns by rows, this is how many bricks we have. It's 60. And is the brick in some kind of group? Yeah, it's in the bricks group. So we can count the number of bricks that are like still on the field divided by 60. Const. Start brick count. Starting brick count. Initial. I should be able to use those constants, right? Together. Like this? Yep. So every time the brick is destroyed, we will count like the percentage. Maybe I am overcomplicating this, but I want this to be like flexible. Like kind of flexible. So get ball speed percent. It should return. Oh, let's return float, because why not? We might want some precision here. So what do? We count how many bricks are still there. Get notes in group. Bricks. Size? Yeah, size. Var brick count equals, and the size is probably int. Yep. So we just returned brick count. Let's cast it to float. Divided by the initial brick count. This should give us the percentage. Wait, but it's like reversed. It will get lower and lower. So something like this, and some parentheses. There we go. So var ball speed is get balls percent, and we should add a method to the ball to change the speed. Function set speed percent. I'm not sure if it's like easy to understand what it means, but we will start with that. And it shouldn't return anything. And we need to do some calculations. So the range will be max speed minus minimum speed. Right. We will multiply it by speed and add it to the minimum speed. This should work. Yeah, if you pass 100 here, you should get 700 plus 300, which is 1000. Yep, and if you put 0 here, you should get 300, which is minimal. Usually you would, like in like a normal software, you would probably want to write a unit test for this. Just to make sure that you know, that you didn't do any stupid stuff with your calculations. Ball speed. It should be fine as like an integer number. So ball, maybe we should use signals for this. Set speed percent. I already don't like that function name. Let's see if it even works. Maybe we should like print that. I need to learn how do you do the like automatic testing for games made in Godot. That would be very nice to have. Ball speed changed. Plus ball speed. And we need to do the casting to string. There we go. Collided with, we don't need that anymore. Collided. Yeah, let's remove this. It just prints collided with brick every time it collides with brick. Okay, the starting speed is wrong. Ball speed change 0. Yeah, it looks like 1/60th. Yep. Oh, we also are printing the angle modifications, which are actually messing up the ball physics now. That's wrong. Maybe we should like That's not good that it happens so often. We might want to fix that ball bouncing thingy. Because for now it's like it very often ends up in a weird state. Okay, the ball speed is actually increasing. So I also need to change the starting speed to minimum speed. There we go. And let's see if it will work fine if we make less bricks. Like, let's say there will be 5 columns. The increase should be bigger now. 0.26. It was 0.013 or something like that. Okay, now what? Okay. The parts of the puddle that are close to the edges have like a angled hitbox. Okay, it would even be more fun if the ball was just going by 45 degrees angle. Okay. Yeah, it is increasing, so that's nice. It's not increasing infinitely. There is like a limit to it. And it's like proportional to how many bricks we have on the screen. If we only had like 1 brick, let's see if I can hit that 1 brick. It should increase to the maximum if we manage to to hit that. Wait, why is it 0? Wait. Oh, because it's calculated before. I see. Before the brick gets removed. Like the brick gets removed after that function ends. So we have like we have the state before the brick gets removed. But the thing is, will we ever have like a 1 brick in a level, like a level with only 1 brick? Like we can fix that situation, or we can just ignore it and assume that there will always be like more than 1 brick at the beginning of the level. Like to fix that, I can just put -1 somewhere, but we will need to make sure that we won't get negative number. Brick count. If we get -1, we won't get to the maximum speed though. Let's try. I think we have a function called clamp. What's it called? Clamp? Clamp integer minimum maximum. -1, 0, 100. No, wait, that's not what we want to. So the first time, yeah, the ball is changing to 0. Wait, what did I break? Get nodes in group node. Oh. I think we had a ball. No. Oh, get 3. Okay. Or we can add 1 here. Wait, but then we can get. Oh, we will never get 0 in the brick count. Because before the last brick gets removed, it will still get counted here. Okay, let's just add 1 here. No, it looks like some kind of hack. Counted before. Brick is deleted. Does it explain the purpose? Not really. So the brick count is like, if there's like 100 bricks and 1 gets deleted, we will still have 100 here. So we are starting with 1 and we are ending with like, it will never be 0. It will be the least value of brick count will be 1. So yeah, it will give 0 here. No, wait. It will be like 100 plus 1 minus 1. Okay. Something like that. Let's see. Let's see how the speed will change if we manage to hit the brick. It's 1. Oh, wait, that's... Yeah, that the ball's set speed percent is misleading because it's not percent. It's like from 0 to 1. Maybe speed factor? Let's call it speed factor. Or multiplier. Okay, yeah, let's leave it like that. Sometimes when I don't know how to call something, I just call it like blah blah blah, and after I like create a function and realize what the function does, then I give the name for the function. And it's usually a pretty good approach, because when you have the logic, you can easily say, okay, This function does this and this, so let's call it that. Okay. Okay, let's bring back the number of columns and the rows. I think it was something like this. Yeah, 10 by 6. And that should be it for the ball speed increase and the player score. Okay, so we can... Wait, give me a second. Okay, we can actually commit and push the change. So let's do a commit. The issue number is 5. So if we commit with issue number 5, wait, we should also save everything. Let's close the game. Save all. And now let's see what changed. Okay, we have the scaling of the ball speed. All right, the speed factor thingy. The bounce variance is returning float now. Nice. Game. Okay. Fine. Wait, what is it? Paddle. Oh, we increased the speed of the paddle. That's also fine. Brick destruction. Okay. Bricks are when ball collides. I think we already committed that. And the ball speed increases with each brick destruction. Okay, commit and push. And it should just automatically close this. Right? Did we push? It didn't close it. But wait, why didn't it close it? I mean, it's not that important, but issues, it created the issue. Oh, because the issue is already closed, I think. Okay, it's fine. I think I moved that ticket manually from done. Okay, let's move it here. The next thing will be score and lives. We have score, we don't have a life counter. The player starts with 3 lives. If the player misses the ball, a life should be subtracted. Subtracted or subtracted, okay. When all lives are used, the game ends. Okay, it's pretty straightforward. Life may be numeric value or could be represented as multiple paddle pictures. Let's start with a number. And it shouldn't be too difficult to represent the lives as some graphical objects. But before that, I will take a short break, so be right back. Why is the be right back screen black? Okay, we need to fix that. Display capture. Okay, we have display capture, and this is probably game capture. Okay, seems like it. Alright, be right back. Okay, let's continue. Let's continue with what? With lives. Okay. Yeah, we do have some basic scoring system, so that's done. Lives probably should be stored in the game scene, which is like the main scene at the moment. Okay. Oh, yeah. Oh, that's score. Variable lives equals 3. We should also store the start. Oh, initial lives. We are using that word initial lives. Okay, let's start with 3. There we go. Okay, and for now it will be like a very simple label. Let's start with something, right? Lives, and I will even hard code it for now. Where is it? Did I just scale this, or did I change the font size? We did change the font size to 66. Cool. That's a very nice GUI. Okay. We do have lives, but we are not dying. So, border, ceiling. We have ceiling 1 and ceiling 2. I can just move that ceiling to off screen. And we can detect the collision with that ceiling. We should also call it floor. I think ball has the collision detection, right? Where is the script? Ball. Collision detected. Yep. Yeah, and I think we will use the signals here as well. So, and also groups. So let's put that floor thingy into a group call, and let's call that group def. No, no, maybe that's not that bad. Def detector. Def zone. Oh, def zone sounds nice. Let's call it def zone. Okay. Let's move it a little bit lower. So, oh, we should also like resize it, I think. We don't want the ball to be escaping the game field. How do we resize that? Move, resize. Can I? There we go. It won't be displayed, so it doesn't need to look nice. Let's put it here. Let's see. Yep. Oh, yeah, it goes off screen. Okay. Okay, now I think it's like somewhere out there. But it should always collide with... Yeah, there is like a very slim chance. Let's make it even bigger. Yeah, that's like more than enough. Okay. but we shouldn't be just, you know, decreasing the life counter. Oh, here is the ball. We should like reset the game state, like the paddle should be moved to here, the ball should be stopped. Would be nice to have the ball like lying on the paddle, right? And like when you press the space bar, it will start. But we need to like prepare for this thing. Like I've read about thing called the state pattern, and maybe we should implement the state, like a simple, very simple state pattern, nothing too fancy. So where is it? Oh, I have that in a different browser. Let me copy the bookmark. Okay, game programming patterns, and yeah, time to do some quick reading. So basically, what we want to have? We want to have like one state which will be like the start state, where you could move the paddle, the ball will, like preferably the ball should stay on the paddle and the ball should not be moving. And let's say you press spacebar, and this is where the ball starts moving. And this is like the different state. So yeah, we will try to do something like this. But yeah, should it be the game state or... Yeah, let's try doing that in the games. I wonder if there's like a way to stop the physics for us, that specific object. Or do we have to also implement state in the ball object? It shouldn't be too difficult. So basically, yeah, this is the article about the state pattern. So when you don't use that, you may like easily end up with the code like that. Like let's say you have a jumping button, and you need to detect if the jumping button is pressed in like the correct moment, so you don't have like infinite jumping. So yeah, you basically want to have like a possibility to switch the object state, and then with each state the behavior of that object changes, and like it look like in this example it will like behave differently for like specific button presses. So this is without the state pattern, and yeah, this is with the like the simplest state pattern. You basically are switching the conditions. Like first you check the state, and then you have the state logic. It might be in like a separate function, for example. Jackson, hello. I'm doing fine. We are making a very simple game, like a Breakout clone. So yeah, so far we have something like this. I am learning how to make games in Godot. So we are not making any like super fancy stuff, but that's the point, to make something simple enough to be able to actually complete that. So yeah, now I'm working on the lives system, and like I want to figure out how to like stop the ball when you die. Or at the beginning of the game, the ball should also be stopped. How are you doing, Jackson? So yeah, I think the state pattern should be perfect for this. Yeah, we might implement the state in both places. Like, it could be like a simple enum state. No, you don't use... Wait, I need to check the... How do you do enum in Godot? I think you use the brackets. Yeah, you do. Okay, so it looks very similar to enums in like C, for example. Kinda weird to see those braces in GD script. Okay, so one state will be like stopped and the other will be moving. I should be able to use the state in this script as well. Like the same name of the enum, it's like in different namespace, right? Okay, let's call it differently. Like stage start. And let's say we'll get into the stage starts state every time you die, or at the beginning of the game. And playing. Something like that. Okay. Where should we put this? Maybe below constants. Here we have the variable current state, and it should be stage start. Okay. Should we even like do something? Oh, on the stage change. Okay, let's implement the state within the ball first. It should be easier. So basically, I think we should like ignore all of the physics processing if the state is stopped. Oh, we don't have the current state variable. Wait, we have some mess here. Signal. Let's move the signal to the very top. Okay, that's kind of fine. We did have state in like below constants, so let's put it in the same place here. Okay. And we will also have the current state here. State stopped. Yeah, like this state and this state, these are like different states. They shouldn't collide with each other, I hope. State stopped. Just return. So now the ball should not be moving. Yep, nice. And if we change the state to moving, I don't think it reloads in real time, right? Yep. Okay, we have some basic, like super basic state. So I'm wondering if this state should be a class, like a separate class. Okay, let's start with the simple implementation, and we can always refactor this later. So what we want to do when the game is in the stopped state, is we want to switch the ball state to stopped, and would be nice to have the ball following the paddle. But the problem is the paddle has its own script for moving. Oh, wait. How about we... Wait, the paddle is moving in physics process. The ball is also moving in physics process. Can I just implement the physics process in the game? Let's try it. I'm not sure if you should like manually change the object position. I've read somewhere that this is like not recommended. Let's see what will happen. Wait, it's not called switch, right? It's called match for enums. Match, yeah, match. We also can just use the if. Let's try using the match. If current state is, we will get some nested code, but it's fine. State E. Oh, you don't need to use the state? Wait, let's actually set the type here. What? Oh, let's stop the game. They are just using match param free. Param free is just it's just a variable. You can use it with variables as well. Okay. So I think we should use the state. Why is it not giving any hints? This will be like a super like not very elegant. But I just want to see if it will work. It should, right? And let's move it slightly to the top. Slightly to upper. Minus 32. I don't remember how big the sprites are. Okay, it kind of works, but I'm not sure how the physics will react to that. As you can see, the ball is like floating around on that paddle. I've read somewhere that you are not supposed to change the position of the physics object, like manually. Like you can do this, but you had to do something after you did that. Okay, but overall it looks kind of fine, except for that, you know, it doesn't update, like it has some like leniency here. Or some floatiness, maybe that's the better word. Okay, reading time, physics process. Wait, we can also read the built-in documentation. Delta will be larger. Okay. Set position of rigid body. Yeah, Godot physics. Let's see what Reddit has to say about that. Oh, the engine does allow changing body position, but it has to be done at the right time or will not work as expected. Integrate forces, yeah. Integrate forces. Here someone says that the engine does not allow you to set the position. Okay, let's read about that integrate forces function before we trust someone from Reddit. Forum. Can I just search it here? Yeah, the searching function kind of sucks in the docs because it doesn't, like, it just shows you everything that matches, but you need to like find the right document. It's not like Google, but we shouldn't be expecting the Google level of search engine everywhere. If you need to alter any of the physics related properties, you should use the integrate forces. In this callback, you have access to the body's physics direct body state, which allows for safely changing properties. Integrate forces. Wait, do I still need to like apply forces? Apply torque? Can I just set the position? Maybe not. Physics direct body state to D. Velocity, inertia, sleeping, total gravity, methods, apply. Oh, you can like literally add some forces. Can I just set the position and just integrate forces? What is sleeping? Currently sleeping. Wujek, hello. We are doing some physics in the game. Maybe I just call integrate forces and that's it. Maybe I should just see what will happen if we start the ball now after like changing its position. Looks complicated. Yeah, we are getting into some complicated territory. But we are just doing like one thing at a time, so we shouldn't be overwhelmed by it. Move left, move right. Let's add a new action called start. And let's react to the space bar. And I don't know, enter. Paddle. Input, action pressed. Okay. And there was an input function. We should use the input function in the game, so we can just start and stop the ball. Function input. There we go. Match current state. The code. Yeah, it might be a little bit boring, so sorry about that. I'm not sure if it's like interesting to look at the code all the time. But yeah, that's like a game dev stream. Add booba. Oh, like this will make it interesting. I mean, we can replace the eyes with the booba. I don't know. For that bricks. Add booba to paddle. With jiggle physics, right? I don't know how to do that. Okay. If it's the stage start, we should set the state to state playing and like vice versa. So the question is, will it loop? Wait, we also need to detect the button pressed. Okay, I already kind of want to have like more complicated state implementation, but okay, let's work with what we have. No, we kind of no. Let's keep it here. The second one is Linux console. I don't have a lot of experience in Linux console, and I worked as a programmer for like 11 years. It is very useful to know it, but depending on what you do, you might not need it that much. So yeah, you don't need to like learn everything. To like actually make something. If it's actually pressed, start. Why is it string here and here it's like a oh because you could okay, you could set okay, we had like parameterized. We do have that as a parameter. Okay, we can have it like hard coded the action here. I don't like how nested it's getting. Wait, this should start and stop the ball where when I press. It doesn't work when I press spacebar. If it's start, it should change to playing, and if it's playing, it should change to start. Why is it not working? Oh, wait, we should also... Okay, this is already getting too weird. We should also change the ball state. Because the ball state decides... I don't like that code already. Moving, but we start with something ugly and we might be able to make it more pretty later. State stopped. Reasoning is retarded because literally in the morning I asked about pointers. How to start programming. I mean, you know, if you want to do something, you need to start somewhere, and like programming, like literally everything, like creative is like so complicated. There's so many things to learn. Okay, what happens if I just do this? It works. We can switch the state. It should also move the paddle to the screen center. So when you die, the paddle should move here and the ball should be there. Spaghetti code incoming, yep. But that's... Oh, and we should also like set the ball direction to the diagonal. Okay, if you hold the space bar, I mean the state will not change by the button press. So it shouldn't be a problem that like the state is looping now between the stopped and moving. Okay, but we need to do some more things. But yeah, if you like prototype something, you can start with ugly code, like to just see if it will work. Like I put something like this, and I was able to like quickly see if it's working properly, right? Because you don't want to spend like too much time working on a beautiful code and then realizing that, okay, that's wrong approach. That will not work. So if you like, you know, don't leave the code in like super messy state after you are done with something, it's fine to write some ugly code just to see if it will work. So yeah, if we add like more and more things to that switches, it will start to be like a lot of code nested within those matches. Like this will have more code, this will have more code, this will have more code. So I don't remember exactly how you do this in Godot, but there was something about like having the tree of states. Let's just try to recreate that. So we can move states to classes, which will implement the state, the basic state class, and that state will have like physics process function and input function, and we will just delegate the calls to the state, and we would be able to like replace the states. We will just try to do this and see. Let's call it state machine. I've seen some tutorial about that, but I will just try to recreate this from memory. And let's add a script here. I don't like this state machine name. Let's just leave it here. Base state? Oh. Okay, let's add some code. Scripts. Oh, it shows you the preview of the code. That's nice. Game states. Base state. Okay. It can extend the node. It shouldn't be a problem, right? Yeah. Class name base state. All right, and we need two functions: physics process, like for now, physics process and input. And maybe like the state start, so we can like the GTA 5 comments, allegedly this code is retarded, but it works. I haven't seen that video about the GTA 5 code. But yeah, when you have like a huge code base, there will always be some weird places. You know, it's not always easy to implement something in like elegant way. Also, you have some deadlines and all that stuff. When you work in a company. Because, you know, you need to sell the software. You cannot just spend months creating beautiful code. You need to like develop the features that the client wants. Yeah, it shouldn't. It shouldn't. Like, I was working at some corporate software, and like when you make a game, like I didn't make a lot of games, but there's like different approach. Like we had the client-based approach, I would say. Like there was a client, like a very specific client that was going to buy our software, and they wanted to have like a list of very specific features. And it was like client driven. Like we couldn't like implement anything we want. We had to focus on the features that the client wants. When you make a game, you usually have like a vision in the team, like, okay, we will make this kind of game with this kind of mechanics, right? Like when you are not working, when you don't have like investors above you that suggest you, oh, you know what, do the battle royale. Like implement some crafting into that game, because like people are buying games with crafting. Like if you have like a creative freedom, you can do what you want. But we were implementing the features that the client want, and there were some deadlines for that. Since it may produce unexpected results. So it's, you know, depends on the projects that you are working on. Like the production process might be different. Like we did have some places in code that we knew that we need to refactor this, like we need to improve that piece of code, but there was a problem that no one will want to pay for it. Like, why do we need to pay you for changing some code that just works? Like, what's the value of that change? And we are like, oh, you know, it will look better. It will be easier to maintain, right? And, you know, the client doesn't care about that, how it is implemented. How does the code look like? They care about which button they can press in that program and, you know, have something called business value in that software. So yeah, there was one at some point we have had like literally no time for refactoring, and it was a little bit frustrating. We knew that there are some places that need to be improved, because every time you had to change something in that code, you spent like sometimes even days trying to change something in that code. And if you spend like, I don't know, let's say a week refactoring that part of the code, the next time you would have to change something in that code, it will take you, I don't know, 5 hours, let's say, instead of 2 days. But yeah, corpo mentality, you can call that way, but also, you know, the client was paying money for very specific things. So if they had a choice, like let's say this month we will give you, let's say, the ability to generate some reports and, you know, add this logic and this logic. Or you could say, you know what, we will spend this month improving our code, so it will be easier to maintain for us. And the client will be like, okay, but why do I have to pay for this, right? what's in it for me? Like, you know, that's yeah, that's complicated. In case of fuck up, you would know where to look so it works both. Yep. It's like conflict of interest. So you could do things like, you know, we can tell the client that implementing that feature will take 2 weeks, but it will actually take 1 week, and we will spend 1 week on improving our code and 1 week on working on the things that the client wants. You could be creative like that. But yeah, like it was like a pretty big corporate structure. So yeah, the money was the biggest force and the biggest factor in deciding on what to do. We did have some like a starting phase when, you know, when you start, there's like nothing to sell, right? Because like there is no code. So at the beginning, we have quite a lot of time to improve the code. But we are also creating things from scratch, so we also could, you know, like design something. So yeah. But overall, it was a very nice experience. We did some cool stuff with the code, and I learned a lot. Okay, let's actually implement that state class. So, okay, let's start with those two things. Physics process. But it shouldn't be this exact same name. And we will not implement this here. And like input processing. Physics process, let's call it input process. Would be nice to also have a function called enter the state. And maybe leave or exit. We will see if we need them or not. Pass. Now we will add the state called stage start. And we will extend the base state. Stage start. Open script base state, no. Let's see if I remember how to implement that. Stage start. No template, inherits base state, nice. Stellar Blade releases June 11 on PC. How much is it? Stellar Blade PC on Steam. No, it doesn't have a price. I do have it on my wish list. Okay, I'm not following my wish list. And this is like a stream browser, so I'm not logged in. Developed by Korean studio Shift Up and optimized for PC. What are the... Okay, there are no requirements yet. Okay, we will wait and see. I mean, I have plenty of games on my wish list that I will probably never buy. Or buy on sale and never play it. Okay, so with the stage start... Basically what I want to do, I want to move that code and that code into that stage start. But we need to have the reference to the ball, and maybe we should return the new state. Works on Steam Deck. Oh, okay. So it shouldn't be a problem to make it work on like a modern PC. That's nice. So yeah, where you have where you develop a product, like, I don't know, when you work on Twitch, let's say, or I don't know, like a shopping website like Allegro or something like that, and you are like the owner of the product, you can basically implement whatever you want, right? But you kinda need to like guess what people will want to use, like what will sell. So it's like a different approach. Like same when you make like an indie game, right? And you're like a solo developer. You have like a total freedom of choice of what to implement. But you also have like a very big risk that no one will buy it or no one will enjoy that what you implemented. So yeah, like you have like different ends of the spectrum. Like I was working in a corporate, and we were like, most of the time we were implementing only what the clients wanted to buy. And yeah. And on the other hand, you can have like a project, like your own project, and you decide on everything. But you need to do some research if it will sell. And you need to find your clients later. But you also have like a one thing that you are selling to everyone. And we had a problem that we had some logic like tailored for each customer that was buying our system. We tried to do some like generic stuff that it will work everywhere, but sometimes you had to like implement a very specific things. And we had like plenty of code, and we knew that, okay, some of this code will be used only here and in here. Like this client will use it and this one, and no one else. Yeah, that also can complicate some things. Like we had some complicated versioning, for example, because, you know, when you have like one game that you sell, you can just have like the newest version, and you always sell the newest version, right? And we have that problem that, you know, let's say we installed the version 1 for client A, and like 2 years later we have installed the version 10 for client B, but we still have to support the version 1. And yeah, sometimes the updates were complicated. So yeah. I would love to work on like a game or like one single product that you sell the same product for everyone and you have like a freedom of choice of what to implement. I would like to see how it differs from the things that we were doing. Okay. So we will have access to input, but we won't have access to the ball. So if I just put the code, let's say from physics process, that's an override. So we don't need that switch there, but we cannot just do this. Where is it? Because we don't have the current state variable, we not have the ball here. Wait, why are we having input processing in physics process? That's wrong. Oh, it's input. I copied the wrong thing. Input process. Maybe we can read the input event. It's getting complicated. Input event. We can replace this input class with input event. Should work the same, right? Input versus input. Yeah, what's the difference? Okay, they are using input processing in physics. Input is OS specific global singleton. Input is a node-specific method which is fired only when an input is detected and does something. It cannot, for example, keep track of where a key or mouse button, for example, is being held down, I assume. Okay, that doesn't sound very convincing. Okay, maybe let's read the docs. Unhandled input. Input map. Okay. Whoa, that's a lot of reading. Do I want to read all of that? Holy heck. Input event. What is input event? Okay. Okay, so we basically use input class outside of the input or unhandled input methods, I think. Input examples. Mm-hmm. Okay, so if I press the button, that input function will get called. So it will get like called only whenever the button is pressed, but here it's like every time the physics is processed. Okay, so we kinda want to have this. We don't need to check if the button was pressed. We will be working on states. Okay, let's switch to input processing. Where is it? Where is the event is action pressed? Okay. Just like this. Okay. That's kinda... Nothing works in this, in those lines. Where is it? The state. The state pattern. Let's make it bigger. State object. There was something like you could return the new state. What's the catch? State machine. Handle input. Okay. Yeah, we do want to have something like this. Delegate the handling to the specific state. Okay, we are getting into some complicated places. Yeah, you can like return the new state. We could also use the signals, I guess, to switch the states. But this also looks nice, like when you press the button, you return the new state and something will change that state. What the heck? Okay, we already have something like this. Current state machines. Oh, here is the code that replaces the state. It's called from the outside. I feel like I'm overcomplicating this. Should I just use the signals? Like the ball is like totally different object. So if we want to change the state of the ball, maybe we should actually use the signals. Like the start the ball, stop the ball, something like that. But we also want to have the handle to the ball and paddle objects. I'm stuck. Maybe do we want the base state to have reference to ball and paddle? Not really. How about here? Wait. So the ball is, let's actually call this ball. So we will have the type ball and we will have the type paddle here. So we could have like a variable of the type ball here and variable of the type paddle. So then we should be able to switch the ball state like that. How do we change the state though? Finite state machine in Godot. With one variable, we already had that. With nodes, okay. State class, small virtual base class, we do have that, and state machine class. Oh, it tracks the current state, changes the current state, and calls the state update functions. All right, we do need to have some kind of, you know, state switching logic. Okay, we had something like this. That's fine. Signal emitted when the state finishes and wants to transition to another state. So So if we press the start action, okay, we will just manually switch the ball state to moving, and we want to switch the game state to playing. So we do want to have that signal. Data? We don't need any data yet. Game states, base state. So we will have like a state name, state path, next state. We will just use simple names here. Okay. What the heck is this? I don't like that code. No. Oh, they are doing some magic here. Like they are finding every state. Oh, crap. This is too complicated. I think I will try to do it different way. Let's see. Game, state machine. I should have made some backup to that code before we started that, but wait, we saved the code that had the ball speed increase logic. So yeah, we are just working on the states now. I think the only thing that I've like actually added to the game was the lives counter, which doesn't work yet. Okay, anyway. Why is it so complicated? I will just put the what I want to do, I will just put these states as variables here. Will it work? Maybe we don't need the... I'm so confused right now. Okay. Init. There should be a function called init, right? Init. Oh, it's not a constructor, right? Do we have constructors in Godot? If init is defined with required parameters, the object with script may only be created directly. So if I have like Something is terribly wrong. Ah, function. Does it even start? Okay, it does. Okay, we didn't break the game yet. So, wait, to make a new state machine, do I just call the new state machine and like pass the parameter? No, wait, the example from init was different. Oh, class name new, okay. Okay. Seems like it didn't crash. Yeah, let's initialize the state machine like manually. It may not be the like automatic approach, but I want to write something that I will understand. like these examples with those. Yeah, that looks like some kind of magic. Like here, you're like here you are like automatically. No, that's not it. Where was it? Here, there's some shenanigans to like automatically find the states that are like somewhere below. Looks cool, but I don't understand it, so yeah. Wait, also Godot map. Yeah, we need to. I think there was something like a map or dictionary or something like that. Maybe let's look for GD script documentation. Eh? It's not called map. Is it dictionary? Dictionary. Oh, you just do this and you can. Oh, you can have something like this. How do you add elements? Or is it like, or you cannot? No, it should have like a put method, right? No? Dictionaries will preserve the insertion order when adding new entries. Okay, how do you add new? To add a key to existing dictionary? Oh, you just do this. Okay. So yeah, this will also have init function. We need to like initialize the ball and paddle. Let's make them private. Paddle and ball. And this might be like the first time I'm doing like anything object related in Godot, so I'm not sure if it will even work. Maybe. Okay, so in the state machine, we will also require paddle and ball, but we will pass it to the init. Okay, and we will have like states dictionary when we will put all states. There we go, and we will like manually add. We will have some hard-coded strings, but yeah, it's fine. So stage start. Oh, it doesn't have class name. Now it should work. New, and we pass the paddle and the ball. Cool. Okay, so we have one state. That's so complicated. So in the game code, we will have our state machine, and when the node is ready, when both the node and its children have entered the scene tree. Let's see. Variable. State machine. Okay. Let's initialize the state machine and give it handles to paddle and ball. How do we go back? Okay. Just like this. Okay, let's see if it crashes now. It doesn't. We still don't know if it works though, but it doesn't crash. So it's okay. Stage start. Okay, so we have input processing. Yeah, if we press the start button, it should start the ball. That should be fine for now. And we also need the physics process. And in the physics process, we will just make the ball stick to the you know, to the paddle. Which is basically this code. All right. Okay, we moved the code from that state, I think. Kinda, yeah. We will have to worry about changing the states later, but let's try to, let's call it old. We will be removing that code soon. State machine. Oh, we need to like propagate the processing for the state machine, I guess. Ah, so it also has to have those functions. That's fine. And we also need to have the current state hidden here. Yeah, it will be hidden within the state machine. So the game itself will not know what state it's in. It's fine. So current state equals this. It's so now we can physics process. Okay. Not okay? Oh, delta. Input process with event. Oh boy. I hope it will be worth it. So the new physics process should just call the state machine physics process delta. Deprecated. We will be removing that code below soon. Input process, and we pass this here, so this will call this, and this will call this. Maybe it will work, maybe not. We should already have the stage start initialized. Let's just see. Okay, let's put a debugger here. Yeah, it enters that code. Nice. Seems like it's working. Oh, we started the ball, but it also stopped immediately. Yeah, it moved a little bit. Something happened. Something happened. So that's nice. We don't have the state change implemented yet. There was a suggestion to use states for changing to use the signals for changing the state. Yeah, let's do this. The signal is here. Finished. So basically, if we press the start button, that should be the end of that of that state, and we should switch to another one. Let's implement that another one state then, which will be called playing state. Can I just duplicate this? Should I duplicate that? Maybe let's not duplicate. Playing state. Oh no, there is state. Let's attach the script. Game state. There we go. Now we can copy some stuff. What do we need in the playing state for now? The ball. We only need the ball. Okay. Kinda weird that the ball didn't actually start. Oh, it's because the game is still in that state that keeps the ball sticked to the paddle. Okay. We do need to implement the state change. So we only need to implement the input and init, I think. So let's do some copy paste. Class name playing state. We need the ball handle, kinda. Okay, and we need the init function, which will only have the ball reference. No paddle this time. That shouldn't be here. That should be in the enter. But let's just do one thing at a time so we won't get overwhelmed with it. Yeah, let's just like manually set it here. I just want to have something that will kinda work. Maybe not perfectly, but it may work. Okay. Let's add that playing state to our state machine. New. Let's pass the ball here. Okay. Now it's time for actually handling that finished state. So finished emit. Yeah, it's emit. And we do have some hard-coded names. That's not good. So yeah, there will be like a lot of things to improve here. And same thing here. Start. And then we need to handle this. Signals. Base state finished. And we implement that in the state machine. There we go. And we just set the current state. To the one from that dictionary, and we trust that we won't get any stupid data here. Should we trust that? Oh, we can like perform a null check here. We can also print that. It will be like a number if I remember. No, we do have a state name. So if new state actually exists in the dictionary, we will do this. Let's actually implement the full switching. Like, let's call exit on the current state, switch the current state to the new one, and let's call the start. Will it start? No, it wasn't. Enter. Okay, let's enter. Enter. It might work. Wait, is it all? Let's see what will happen. It's not ready yet. Okay, debugging time. Let's put some breakpoints and see if it's actually working. Okay, we are in the stage start state. The ball should be moving. That's it. Are there? Oh, we do have some errors. Create instance error. Wait, when did we get those errors? Clear. Okay. Create instance. GD script. State machine GD init. Method expected 2 arguments but called with 0. This one. Okay, there must be an error in the... No. State machine init method expected 2 arguments. It does have 2 arguments, but called with 0. Wait. Oh, maybe when the game starts, it tries to create that state machine. Oh, that's bad. It's like an instance of the state machine here. Already. Maybe we shouldn't be using... Maybe we should like manually call this thing. Maybe we can just reference this. Yeah, let's do it that way. Maybe it's not the most elegant solution, but wait, but the crap. Ay. Oh, the state machine doesn't have init now. It's fine. Okay, we broke some stuff. What are the errors? Node stage start has the same problem. Okay, how do you make a state with oh no. So I think when you put something here, it gets like automatically created. But since it has a custom init function with parameters, yeah, the object with script may only be created directly. The script initialization will fail. This is what happened. This is what happened. Okay, time for some dirty hacks. We won't have init, we will have initialize. I kind of don't like that, but Wait, and those states are like singletons? Yeah, we will just call initialize on that. I just want to have something that will not crash. Yeah, I will need to read about the state machines in Godot or watch some tutorial again, because this is not how we are supposed to be doing that. Okay, let's stop the game because it's messing things up. Okay, no more new. That's for sure. So yeah, we will just have this. Can I do this? Oh, I don't need that even. State machine. Initialize. Maybe it will work. Maybe it's not that bad. Initialize. It will look very similar. So we can also make this return self. Like this. So we can have it inlined like that. Playing state, initialize. Oh, and we reference this by the dollar notation. Maybe it will work. We don't have errors. That's nice. No, we do have. Delta is never used. This is just warnings. Physics process old. We don't need physics process old anymore. I think. Yeah, let's just remove this. So basically, we have moved the state-related stuff to states, but it's kind of dirty implementation for now. Signal finished is declared but never explicitly used in the class. What do you mean? I'm using it here. I'm emitting that signal. Okay, let's implement this enter and exit. So on the enter of wait. On the enter of stage start, can we just like stop the ball? Velocity? The yellow things are warnings. Velocity is a vector, right? Zero. Shouldn't be modifying the velocity here, but no, wait. We don't want that. We want to have the state of the ball set to stopped, and we get rid of this one here. Yeah, that's how it is. That's how it is. We might want to also work on those, on some of those warnings later. Where was I? Okay, on the start of the state start, the ball should stop. And the ball should follow the paddle. And we should switch to the playing state when we press start. Looks quite nice, I would say. And at the enter of the playing state, the ball should be moving. Yeah, remove that. Start. Playing. Start playing, okay. Okay, we cannot switch states apparently anymore. Why? Disconnect. Let's try again. State machine, connect. It should call that function when we press this space bar. It just doesn't. The question is why? What kind of event is this? Oh, it's probably like a mouse move event. Let's move that breakpoint here. Okay, it does emit the signal. Will we enter that function though? We won't. That's quite bad. We emit the signal. State machine. No pictures at all. Each states live in a separate script. Duplicate code, state class. Implementing the states. Something is wrong with that signal. It's not getting handled. But why? Standalone expression. The line may not have. Oh, okay. Yeah. Oh, this is why the ball is not starting. This should work, maybe. Okay. Ah. Also, oh wait, the state machine should also call enter here at the start. Next state. Oh, we are not switching to the new state. Or are we? No, we are. Current state is a new state and enter, but this function doesn't get called. Yeah, nothing happens. Okay. Event. If action is pressed start, it is pressed. The signal is getting emitted. And that's it. This should just work. Okay, maybe we can reset the project. Sometimes it helps. Or maybe I just broke everything. Let's remove this. Well, maybe it actually is not used. The variable sign has the same name as built-in function. Okay. That should be one warning less. Parameter delta is not using in the paddle. Okay, because we are like affecting the velocity. Okay. base state. Fair enough. Okay, we have only 2 warnings now about the signal. Sure. Why is it not working? Base state finished. Target state machine. Looks pretty fine. Looks similar to what we have. Yeah, and they are using emit in the state. Player state has... Oh wait, the signal is in... here. We do have that. We have base state and we have signal finished. Oh wait, maybe because it's a node, it's like a different instance of that signal than this. Maybe it shouldn't be a node. This should not be a node. Let's detach that script and let's remove that. YOLO. So the base state is here. And I think I need to like manually attach the signal here because it's like no longer working. Oh wait, each of those nodes have... Can I attach the same function to handle that? Should be fine, right? No. Disconnect. Disconnect. I want to use that function on state, let's call it on state finished. Can I attach? Oh, receiver method. Okay. It's attached to the same function. Let's see. It works. It works. Nice. All right, it does exactly the same thing that it did before, but we have state in the game. So we no longer have that complicated logic here in the main game script. We just call the state machine to process the physics or to process the input. And the rest is handled by the state machine. Okay, it works. It does work. What's the error? Oh, it is used. Like, we can ignore this. Oh, it's late. I think we should end the stream. So yeah, we haven't implemented the score and lives like properly. We are not losing lives yet. But it shouldn't be too hard now. I wanted to prepare, like when you lose a life, this should happen, like the reset. Yeah. No, we can do like one more thing at the stage start. Wait, how do we set the paddle position to this, to like the middle? How do we get the get screen center? You don't find get viewport rect? Let's see. Wait, size? Get viewport rect. Not found in base. Oh crap. Let's just see what happens if I like hard code this. Position x equals, I don't know, 300. Let's see what will happen. Okay. It kind of works. It's like not the most elegant solution, but we don't have time for anything better for now, so let's leave it to do. There must be some easy way to do this. Yep. Okay, also why we should no, it's fine. Okay, it's fine. Okay. That's all the time that I had for today, so yeah, next time we will be working on the lives. So yeah. when you die, like this should happen, and you should get one life less. All right. So yeah, thank you everyone for watching, and yeah, have a good one. Hope to see you again soon. Bye bye. Bye Avito. And bye Vujek. And bye anyone who was here in the chat or lurking today. So bye bye.